So now I'm on Desmos, and just to demonstrate why the y equals mx plus c works. And I just want to, currently on the screen we have y equals x. And that's like the simplest straight line. And you could say that it's got a gradient of 1, because if you have a look in here it's gone up by 2 from 0, and it's gone along 2. 2 over 2 is 2. Sorry, 2 over 2 is 1. And where does it cross the y-axis? At 0, 0. So its y-intercept is 0. Now, if you remember from transformations of functions, when we multiply something by the x by a constant, we stretch it, and this is what that kind of looks like, and we stretch it along the y-axis. So this is what stretching out the y-axis looks like. And notice how that line's getting steeper. So that is why when we increase m, which is our gradient, the line becomes steeper. And if we just reset this to normal, and I adjust m on here, we can see it is becoming steeper. And then, if you also remember from transformations of functions, what adding a constant to the end of a function does, shifts it up and down. So it's now our red one is y equals mx plus c, and it's going up and down as we change c. And notice how every point's being shifted, but that means that the y-intercept will also be shifted by c. That's why we can still say that the y-intercept is still c. And another important thing is what happens when, well, at 0 gradient, 0 times x is 0, so it's a flat line. And then if we go into the negatives, they'll go downwards, right? That makes sense because gradient is rise over run, and it's a way of saying, okay, as I shift to the right, how far will I go up? And so going up is positive and going down is negative. So if you're going to the right, if when you go to the right, you go down, that would be a negative gradient. And what happens if we start making m infinitely large? Like if we say it's 9, 9, 9, 9, 9, 9. You can see it becomes a bit of a vertical line, right? So, and that's why when we, allow me to show you an example. When we have vertical lines, x equals 5, for example. If we were to write this as, if we were trying to figure out what the gradient is, we'd be trying to do rise over run. So say at this point, okay, at 5, we're at 0, but then at 5 we're also at 2. So we do 2 minus 0, that's our rise, that's fine, we'd go up 2, but we've gone along 0, and you can't divide by 0, so its gradient is undefined. That's all I have, and I hope for explaining why that y equals mx plus c works. If it's useful, actually I will go into this now. I'll talk you through those other ones. For example, y minus y1 equals mx minus x1. This comes from m equals y2 minus y1 over x2 minus x1. We literally just multiply that denominator to get that. And now, basically what this is saying is we can use this as a way of describing a straight line, because when we describe a straight line, you keep at least the y and the x as unknowns, as variables. So all you need to know is one point. And then you could substitute the coordinates of that point in there, and you've got, and then if you had the gradient, and then you've got your line, if that makes sense. Because if you've got a point on here, and you know the gradient, there can only be one line that it can be. It's only one line that it can be. And this essentially works because for any 2 points on the line, if you divide y2 minus y1 over x2 minus x1, you get the same gradient. So you can actually generate, as long as you've got 1 point ready there, you know that you can actually express it as any y and x, which is why you can actually use it to express the whole line. And the other form is something like ax plus by plus c equals 0. That's just when you put everything on the one side, you clear all the fractions and put everything on one side. And that's just algebra. It doesn't really need that much explanation, I don't think.